Hi, everyone. Thanks for having me here. My name is Tom Brand, and I'm a product manager at Starkware for almost 3 years now. I lead StarkNet in the company, and today we're going to discuss Starkware visions for StarkNet and what road we lay ahead to get to this vision. And we'll start by describing very high level what is StarkNet. Then we'll continue to understand on what foundation it lies. And afterwards, we'll understand how we plan to get there. And at the end, how StarkNet will look like. So let's begin. So StarkNet is a decentralized permissionless ZK-Rollup, which will offer a scalable and secure Ethereum-like state. And what that means is that, first of all, StarkNet is a layer 2 on top of Ethereum, which will use the ZK-Rollup protocol. I won't elaborate about what exactly is ZK-Rollup. There are a lot of material on it online, but in few words, ZK-Rollup is a scaling solution for Ethereum that utilize validity proofs, and in the case of StarkNet, Stark proofs, in order to prove state transitions on layer 2 and verify them on layer 1. StarkNet will offer a ZK-Rollup which will be permissionless, both for the operators, the provers, and the users. And the users will be able to write and deploy general computation contracts, which will all be in a composable state, meaning all the contracts will be able to interact with each other in the same way that they can do today on Ethereum. So this is the vision for StarkNet, but more importantly is that StarkNet lies on very solid foundations. And those foundations are what we at Starkware have been working on for the last 3 years. So first of all, we have Cairo, and maybe you have heard about it, but Cairo is our Turing complete language for scaling dApps using Starks. I will elaborate in a second, but basically this is the way that developers and even us at Starkware can write programs and generate posts to them. The second foundation is the Stark provers, which is the actual software stack that allows us to take those Cairo programs and generate posts to them. And lastly, we have StarkX, which is our production tested applications that uses all this technology on LiveNet on Ethereum today. So let's go into each one of those and understand why those 3 foundations are a very important first step in order to arrange for StarkNet. So first of all, Cairo. As I've said, it's a language for writing a scalable dApps. And what the novelty of Cairo is that if before you wanted to write, to be able to prove statements in proofs, you needed to write specific circuits or to have high-level languages that compiled into specific circuits. And what Cairo allows us to do is to not care at all about circuits and only write programs. And in the same way that a CPU can execute a program in a specific circuit, Cairo allows the proof to prove the execution of any program. And more importantly, Cairo allows us to do all this, all those things in an efficient and secure way. Statements that you write in Cairo can be as efficient as you would have written them in a specific circuit. Cairo is already in production on mainnet today, as we'll see in a second on our StarkX instances. And also it is available to the public. I mean, it's open source. Anyone can learn Cairo today and start using it. And if you wanna read more about it and understand how to start learning it, you can go into cairolang.org. So Cairo is the first pillar, and this is what allows us to write programs to be proven. The second foundation is the Stark provers, which take those Cairo programs and generates proofs to them. And what's important about provers is that they will be powerful. And fortunately, Starkware has the most powerful provers in the world. And they are all tested and deployed on mainnet. So just to give you some numbers to the capabilities of those provers. So the Reddit scaling bake-off was, I would say, a competition that Reddit did in order to check scaling solutions for Reddit. And in this competition, we demonstrated how the Stark provers can generate a proof to a 300K transactions in a single proof, which resulted in a 315 gas per transaction. So this was some kind of a demo, but on actual production system with the immutable StarkX, we demonstrated on this April how we can generate proofs to 600K NFTs mint in a single proof, which resulted in less than 10 gas per mint. So those are all real numbers on mainnet, and they demonstrate the power that the Stark provers have. And the last foundation is StarkX, which are actual applications in production on mainnet that are live since June 2020. We already have multiple deployments on mainnet, and much more are coming soon. So first of all, we have payments and spot trading on Diversify. We have derivatives trading with the YDX, and minting and trading of NFTs with Immutable X. And part of the motivation for us to develop those StarkX applications is to ability to dog food our toolchain and to be able to use the technology to build real world needs. So those were the foundations for StarkNet, and this is the way we see it is step 0 on our road to StarkNet. And going forward, we continue in a stepwise approach, meaning we start by building the basic building blocks and then expand them to a wider system. So the first step will be to create what we call the single app ZK-Rollup, meaning, okay, we'll elaborate about it in a minute. The second step will be to take this single app and expand it to a multi-app ZK-Rollup, meaning multiple applications can live in the same ZK-Rollup and they can interact with each other. And the last step will be to take this this network and decentralize it in the sequencer and prover level. So let's dive a little bit into each one of those steps. So the first step, as I said, is a single app rollup. First of all, let me say that it is already expected on testnet in a few weeks. And what this step will offer developers is the ability to write, deploy, and run StarkNet contracts, which will implement arbitrary logic, meaning anyone will be able to write StarkNet contracts, implementing them whatever they want, and the rollup they will be able to deploy it and send transactions, interacting with them, and everything. And the state transition of those contracts will be proven on mainnet. This will actually be the first ZK-Rollup, which will be available to the general public, that will support developers writing general computation, and this computation being proven on Ethereum. So as I've said, this is expected already in a few weeks on testnet, and everybody will be able to experiment with it. The next step is to, and I see that, let me move myself a little bit. Okay, so the next step is to take this building block, the StarkNet contract, and to expand it into a multi-app rollup. We expect this to be live on mainnet, not on testnet, by the end of this year. And what we aim to offer here is an Ethereum-like permissionless interaction, meaning everyone will be able to deploy their contract on this network. Those contracts will be able to interact with each other. And what developers can expect, as I've said, composable smart contracts, seamless interoperability with layer 1. And what I mean by that is that smart contracts on layer 2 will be able to use a communication protocol to interact with contracts on layer 1. And just shortly to describe what I mean here, since in ZK-Rollup state transitions are final at the moment that they are accepted on chain, and there is no dispute period or something like that, this allows us to have atomic transactions between layer 2 and layer 1. Developers can also expect multiple signature options, meaning either using regular Ethereum signatures or more efficient Stark signatures. And of course, because this is the goal of StarkNet, all of this will be with massive scalability, meaning if we take into comparison the size of scalability that we see today on StarkX, so we in some of our system we can see up to 1000x improvement in scalability. So this is what we aim also for StarkNet. And once we have this layer, the next step is to make the operators and the provers permissionless, and by this to offer a full censorship resistance mechanism. And one of the, and since we're a layer 2 on top of Ethereum, we rely on Ethereum consensus mechanism and the validity proofs in order to leverage and to offer much easier permissionless mechanisms to our system. We're also aiming to design some crypto economic mechanisms to incentivize a better functionality of the system. But the security of the system will rely solely on the validity proofs and the security of Ethereum, and all the crypto economic mechanisms will allow to have a better functionality and more efficient operation of the system. Okay, so before we go into the last step, so as I've said, this is the roadmap for StarkNet. Step 0, which are the foundations for StarkNet, is already done, and all parts of it are in production on mainnet for at least a couple of months. And the first step will be on testnet, hopefully in a few weeks. So if we just summarize a little bit what we discussed and look at it from a different angle, there are multiple fundamental advantages for StarkNet. And I will start from scalability, and let me try to argue that this is one advantages that we have over other scaling solutions. So in a ZK-Rollup, the bigger proof you are able to generate, the more scale you can provide. And as I've said, currently we have the most powerful provers in the world. So this allows us off-chain to generate the largest proofs that anyone can offer. And what limits us from scalability perspective on-chain is the fact that we need to post some of the data. But since we write everything in Cairo, there can be many sophisticated mechanisms that we can implement on top of the way we publish the data that will allow us to have the smallest data footprint. And just to give like an idea of what I mean here, it is quite trivial to implement in Cairo Lempel zip or some Hoffman tree compression algorithms. And this can allow us to utilize the fact that Cairo is just a programming language and not some circuit-specific language to implement compression algorithms for this part. So this is the advantages of scalability. From security perspective, which is, I would say, equally important, first of all, we use a ZK-Rollup, which inherits all the security properties of layer 1, meaning state transitions are only accepted on L1 if they are valid, and all the data which is required to know what is the state is present on L1. And maybe more important than that, is that all the technological stack that we have is already production tested, meaning our provers, our language for writing proofs, and actual applications that we develop are already running on testnet, on mainnet, sorry, handling millions of value locked in them. And this is a very important part in the security aspect of the system. And lastly is the state finality of the system. So again, in a ZK-Rollup, in the moment you verify the proof on L1, the state is final. And this allows us for a very, the first advantages from this point of view is the capital efficiency. So there is no dispute period. Users can move their funds in and out of the system in any state transition. And as I've said before, it allows us to create interoperability between L1 and L2, meaning contracts from L2 can call directly to contracts on L1. And the moment the state update will happen on L1, the call on the L1 contract will happen. So this is just to taste some of the fundamental advantages that StarkNet have over other scaling solutions. And if I want to summarize what we've discussed, so first of all, StarkNet is a general computation ZK-Rollup which offers composability and the experience of Ethereum. And it offers the security, the capital efficiency, and the scalability of a ZK-Rollup. And most importantly, it lies on solid foundations. It lies on Cairo, it lies on StarkX, which is deployed on mainnet, and it lies on the Stark provers. And hopefully you'll be able to get a taste within a few weeks. And I'm very eager to see where this road takes us. Thank you very much.